Welcome to class 19 of Java, where we are going to understand some more programs on for loops. So first program that we are going to understand, write a program to read a number and print a number of factors. So in the last video we have seen how to calculate or how to print the factors of a given number. Let's see example here. So this program is printing the number of this program is reading a number and printing the factors. Okay, so here if n modulus I is equal 0, then I is a factor of n. So therefore we are printing the I. Okay, so this program is printing the number of factors. Please, it is printing prints number of factors. Actually this program is what print number of factors. Actually this is the program. Okay, now the same program code I will copy here and I try to change the code here. Let's see how can I do that. So the same code I am now putting over here. Just wait please. So here I am going to copy paste the program. Okay, let's say that here I am going to paste it. Okay, so this program is generally printing the factors. Let me run the program and show you the output first of all. So I am giving n is equal to 6, therefore it is printing the factors 1, 2, 3, 6. Okay, factors are nothing but divisibles. So 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3, 6 is divisible by 6. Okay, these are factors. Please go through the last video. Now in this program what I would like to do is I would like to calculate the number of factors. Okay, so these factors I want to count it, therefore count. So I am going to implement the counting logic now. So I take a variable called as count is equal to 0. So I would like to count how many times these factors it is printing. Okay, so therefore I just write count plus plus, that's it. So whenever it goes into the if and prints the factor, there it will increment the count by 1. So I am counting the number of factors. After the loop I am going to print on the monitor. So sys out. So I say number of factors, okay, is equal to plus a count. So this count will print the number of factors that it is calculated. Okay, right. So as I am using here print statement, here you will not get a new line. Therefore to get a new line I will give /n please. Okay. So therefore I run the program once again. See, I give here n is equal to 6. When I give n is equal to 6, now I got number of factors is 4. Okay. Similarly, now I run the program where I am giving what 30. Okay, 30. Now I got the number of factors is what 8. See, this 30 is divisible with all these particular numbers. Therefore, number of factors is 8. So this is what the counting logic. Okay, this is a counting logic. And remember, please, this is a counting logic. So let me copy this program. And here I paste as a reference the first program, read a number and print the number of factors. Okay, right please. So this is what let me control Z and come here and print. Okay, fine, good. Next program that I am going to work with here it is, write a program to read a number and print it is a prime number or not. No, I don't want to explain this program. Okay, first of all, right, let's say here this second program we go with. Write a program to calculate 1 minus 2 plus 3 minus 4 plus 5 and up to n. Okay, so let me explain about this particular thing. Let me open the Boogie board. Okay, let me say here. Yeah, so what is this program is all about? Let me tell you. So what is happening here? It is I want to calculate like this. What is that is 1 minus 2 plus 3 minus 4 plus 5 up to plus or minus n. This is what happens. Okay. So here what is happening is this is actually sum of 1 to n numbers only. Okay, I repeat here, sum of 1 to n numbers only. But the only thing here it is the signs are changing. See, the signs are what? Changing. So how can you change the sign of a value? Okay, how can you change the sign of a value? So I want to get the sign like this, plus, plus, minus, plus, minus, plus, minus, like this. Alternatively, I would like to change the sign. For this, what we do is, for this logic, I take a variable called as sign. Sign is equal to 1. 1 means positive. Okay, 1 means positive. Is that clear? Minus 1 means negative. That is what the indication. Okay, this is plus 1. Got it? Now, how can I change the sign alternatively? Sign is equal to sign multiplied by minus 1. Now see, what is the sign is 1. 1 into minus 1 becomes what? Okay, 1 into minus 1 is minus 1. Minus 1 will be stored into the sign. Now the sign changes to what? Minus 1. Minus 1 means it's a negative sign. Okay, again apply the same formula. Sign, what the sign is? Minus 1. Minus 1 into again minus 1. Now it becomes what? Plus 1. Plus 1 will be stored into sign. So sign is equal to plus 1. Now you got what? Plus sign. Is that clear? Like this you will be getting positive, negative, like this. So this is the basic formula that is used to change the sign. Okay. Now let us say, now how can we get the values like this? Plus 1, minus 2, plus 3, minus 4. How you get? So I can write the formula like this. I into sign I write here. Okay. See, when I is equal to 1 and sign is equal to 1, 1 into 1 is plus 1 will get. When I is equal to 2 and the sign will change to minus 1 with the help of this formula, okay, minus 1, then it becomes what? Minus 2. Similarly, when I is equal to 3 and the sign will change to what? 1, then it becomes what? Plus 3. Then when I is equal to 4 and here the sign will change to minus 1, therefore you will get what? Minus 4. Like that you will be getting alternatively, okay, alternatively you will get plus or minus, okay, like this. Okay, so the formula that I can use finally is I into sign, and sign always I change by using sign is equal to sign into minus 1. Okay, so let me write the program over here. Let me write in the Eclipse. Okay, so I read the value. First of all, let me say that here I take a variable called as sign, sign. Sign is equal to 1. 1 means positive value. Okay, sign is nothing but 1 means positive. Okay, so I read the value for n value I am reading from keyboard. Now what I am going to do here it is, let me show you. Right, let me close this program. Right, fine. Now the for loop is running for 1 to n times. As I have to calculate the sum, therefore I take one more variable, sum is equal to 0. So what is the formula to calculate the sum of 1 to n? Sum is equal to sum plus I. Okay, I. So I is equal to 1 to n, 1 to n. So all 1 to n numbers are added to sum. But the sign of this 1 to n should be changed. Therefore, I write here I multiplied by sign. Okay. So this is, if sign is 1, then it becomes positive I. When sign is equal to minus 1, it becomes minus I. Okay. Then alternatively, I will change the sign. See, I will change the sign. Sign is equal to sign multiplied by minus 1. Alternatively, the sign will be changed here. Okay. So let me show you very clearly how it is going to work. Okay. So let me show you the variable, the values. Okay. Sys out. Okay. Sys out. Let me show you this particular I into sign. I will show you what is the values that you are getting. Okay. So I into sign. Let me run the program and show you actually how you are getting the number. Suppose I give 5. See, I am getting 1, minus 2, 3, minus 4, minus 5. So this is I into sign is now is doing this particular thing. See, and alternatively the sign is changing here. This is the sign it is changing, please. Okay. See, if you want to see the sign only, I give only sign. See, now the sign you will be getting here. Please let me save the program and I run the program. See, only sign you are getting here. 5 I will get. This is the case. See, 1 minus 1, 1 minus 1, 1. So this is the actual thing which is changing the sign. Okay. This is what changes the sign. Okay, positive to negative, negative to positive. So now this sign I am applying to the I by multiplying. Got it clear, right? So this is how you are going to do. So what you are doing, please, you are calculate 1 minus 2 plus 3 minus 4 plus 5 and so on. Okay. So how you are going to get this 1 to n numbers changing the sign means the formula is I into sign, and sign change by using sign is equal to sign into minus 1. Okay, right. After the for loop, what I am going to do is okay, now I am going to write sum is equal to, what is the sum, please, plus I am going to give the sum. Okay, so let me show you the, okay, now let me comment this one. Okay, it's not required now. Okay, right. After calculating the complete sum, I am printing on the monitor now. So therefore I run the program. Here I give n is equal to 5. Now you got 3. Okay. Similarly, I give n is equal to 10, therefore I got minus 5. Okay, so this is what the program. So here you have to understand the sign logic. This program is actually, I have explained to understand how to change the signs alternatively, like this: positive, negative, positive, negative, how to change the signs, okay, alternatively. That is what I say, it is a sign logic. Okay, so remember this sign logic, please. Okay, let me copy paste the program here. Right, this is what the program that we have seen. Right, fine, this is the program. The next program that we are going to understand here is write a program to calculate 1 by x to the power of 1 minus 2 by x to the power of 2 plus 3 by x to the power of 3, okay, 4 by x to the power of 4 up to plus or minus n by x to the power of n. Okay, so this is what you have to calculate now. This is what you have to calculate now. So how you are going to calculate? Let us understand this particular thing. So this, what is the common thing for this program and this program is alternatively the sign is changing. See, this is a positive, negative, positive, negative. So sign logic, however, we are going to use here. Okay, that logic we are going to use. So let me write here, please. Let me copy paste this also for your reference purpose. For your reference purpose, I paste this also. Right, fine. So let us come to this program now, please. Let us come to this program. Right. Now in this program, what how we are going to do? Let me explain the logic. So here, what we want to do, please? 1 by x to the power of 1 minus 2 by x to the power of 2 plus 3 by x to the power of 3 minus 4 by x to the power of 4 up to n by x to the power of n. This is what you want to calculate. Okay. Now let me explain the logic very clearly. Okay. What is this particular thing? What is this is? Means what are these values are? These values are related to what? Sorry, up to here, up to here. This is related to what? Can I say I? I where I is equal to what? 1 to n. Okay, I is equal to 1 to n. So I by what I can write? X is a common variable. Okay, so x to the power of, see, 1 2 3 4 n means this 1 1 2 2 3 3 4 4. So therefore x to the power of I can write. Okay, where I is equal to 1 to n. Okay, so I have converted this total expression into one particular term I have converted. This is what the one term I have converted. Okay, so the formula to calculate this complete expression is, I can write sum is equal to sum plus what is that is I by, okay, x power I. This is what multiplied by sign. Again I can put here sign, alternatively the sign will be changed. Okay, right, sum is equal to sum plus I by x to the power of I, then multiplied by sign. Clear? This is what, how can we calculate? So this how this particular complex expression you can convert into a single formula. Okay, but how can you write x to the power of I in a Java? There is a class called as math class is present, math dot. Okay, there is one method called as power of x comma I. This is what, how can you write it? Okay, this is how you can write x power I. Okay, let me explain this program, or let me write the program here. Okay, so this is what I am pasting the logic. Right, now here I come, the same program I am going to write, please. So I am going to calculate that powers, same program in the main. So I read the value for n. Okay, I read the value for n. Okay, n. Also I have to read the value for, right, double x. Okay, and here sum also I'll write what? 0.0. Why I am taking this particular sum and x as a double means, if you observe carefully this particular expression, see, we are getting divisions or not. So when you are getting the divisions here, whenever you are doing divisions, you get the answers in what? Decimals. Okay, points you will be getting. That is why I am taking as double. Okay, double x, and sum also double. Okay, right. So enter the value for n. Similarly, I also read the value for x. Enter the value for x. Okay, x. How to read the value for x? X is a double. Therefore, I say next double. Okay, next to double, right? This is what. So reading the value for n completed, reading the value for x completed. Now we are going to write the code. Okay, fine. So now we write the code. How? Let's say how many terms we have to calculate, please? N terms we have to calculate. So loop should run for n times. For I is equal to 1, I is less than is equal to n. Okay, I plus plus. Okay. So therefore, now I am going to write this one. So what I can write now? Sum is equal to, the formula sum is equal to sum plus, see, sum plus, what is that is? I by math dot power of, okay, power of x comma I. Okay, whatever the answer that you will get multiplied by, okay, whatever the answer that you get with this calculation, that multiplied by sign. Okay, sign. So I by x to the power of I, okay, multiplied by sign. Alternatively, the sign will change and it will add to the sum. Okay. Now sign alternatively we have to change. So sign is equal to sign multiplied by minus 1. Okay. Or, okay, or you can also use compound assignment operator. Sign multiplied is equal to minus 1. Like this also you can write. Okay. For just reference purpose I am giving, right? Okay, so fine, this is completed. Now I am going to print here, sys out after the loop. The complete sum is equal to, what is the sum is equal to? Plus I pride sum. That's it. Okay. So let me run the program and show you what is happening here. So n is equal to 5 I will give. So the answer is x is equal to 2 I give. So this is the answer. Is okay? So once again I run the program. Suppose 10 is there. Okay. I give something called as 5 here. So this is the answer. Okay. So this is how we can get the answers for this particular calculation. Okay. So therefore, let's say Control C. And here I am going to paste the program. So this is the program that I am giving for you. Okay. Fine. Next program that I am going to explain over here, it is, okay, write a program to print this particular thing. Okay, 1 0 1 0 1 0 1 0 1 0. So alternatively you have to print 1 0 1 0 like this. You have to print, please. Okay, these are the simple logical programs. How to print alternatively 1 0 1 0 1 0 like binary digits. Okay, alternative numbers. Okay, let me explain very clearly what is happening. Okay, let me run the program. So let me close this one and write here. Okay, I take a variable integer I. For I is equal to 1, start, I is less than is equal to 10, step I plus plus. Okay, chalo. This is the program. Now if you observe carefully, how many numbers are there? 1, 2, 3, like this, 10 digits are there. Okay, so 10 times. 10 times I want to print. What I am going to print is sys out. See, I am going to create print. Okay, print method. Okay, print, and I give some space also here, plus, and I say what I. Because I want to get the answers in the same line itself. Okay, same line I want to get it, right? So therefore, let me run it. So let me run the program. When I run the program, I am getting what? 1 to 10 numbers. See, 1 to 10 numbers. I got it. Okay, 1 to 10 numbers. I got it. But what I should get is, I should get the 1. Okay, odd number 1. 2 even number, remainder 0. 3 odd number. Okay, 1. 4 even number, 0. 5 odd number, 1, 4, 6 even number, 0. So I want to get the reminders of 1 to 10. So how to get reminders of 1 to 10? This is I modulus 2 reminders. That's it. So I reminders I want to print. Okay, odd number means if I is an odd number, it will print 1. If I is an even number, it will print 0. So like this, I want to print the, yes, this is what. Okay, the reminders of odd and even numbers between 1 to n. Okay, this is a simple logic. So therefore, let me copy paste. Remember this logic, please. This is the program. Okay. Lastly, I would like to explain one more program, which is what write a program to read a number and print it is a prime number or not. Okay, prime number or not program that I would like to explain. So let us say that. So did I copy this particular thing? Let me check out here. Yeah, I have copied. Fine, let it be. Let me clear the screen. Okay, erase. Now let's say please here what I mean to say is prime number or not. Okay, prime number or not. Now what is a prime number? Now the question comes here. What is a prime number? Prime number or not? What is a prime number? Any number, okay, which is divisible by 1 and itself is a prime number. Otherwise it is not a prime number. Okay, means if you take a number n, that n should be divided with 1. Okay, should be divided with 2, should be divided with what? 3. Means in the programming we will be writing like this please. Okay, n modulus 1, n modulus 2, n modulus 3, n modulus 4, like this up to n modulus n we have to divide it. Okay, n modulus n, sorry, this is n modulus n we have to divide it. Okay, means if it is divisible with 1 and itself, if the n is divisible with 1 and itself, then the number is prime number. Okay, otherwise it is not a prime number. Okay, but what I am going to do is I am not going to divide with 1, I am not going to divide with what? N. Okay, because everybody knows n is divisible by 1 and itself. Okay, so my logic begins from 2 to up to which number I divide means 2 to up to half of the number only. N is equal to n divided by 2. Because if n is equal to 10, the chances are there this 10 can be divided by up to 5 only. 5 means n by 2. 5 means n by 2, half of the number. So any number if you take, the divisible possibilities are there up to half of its number. For example, n is equal to let's say 25 you take. So up to which number the possibilities are there? Up to half of the number. 25 half is 12, not 12.5, 12. So 12 ones are 12, 12 to the 24, there is a possibility. Okay, this is. But 12 3s are, no, it is 36, not divisible. Okay, not at all, chances are not there. So for any number, you get the divisible chances up to half of the number only. So what I am doing is, I am dividing the number from 2 to half of the number only. Okay, so for prime number logic, you divide the given number from 2 to half of the number. If at all, okay, if n is divisible with any one this number, then the number is not a prime number. Okay, if at all, if n is divisible with, okay, divisible by any number, then it is not prime number. Otherwise it is a prime number. Okay, I repeat, you divide n by 2 to half of the number. If at all, if n is divisible with any number, if n is divisible with any number, then it is not a prime number. Okay, if it is not divisible with any number, it is a prime number. Okay, this logic we are going to implement now. Okay, this is the logic that we are going to implement now, right? Let us see how can we do it. Let us write the same. Okay, so let me get back to the previous program, please. Logic. Okay, this is. So up to here we are reading the number. Let's say we are reading the number up to here. Okay, scanner NI sign is not required. Okay, right. So please n I am taking. Okay, right. So in this case I am going to take one boolean variable. Yeah, best example. Boolean. Okay, prime is equal to false. Prime is equal, let me say, I consider it is true. Okay, prime is equal to what? True. My assumption is n is a prime number. Okay, so assumption is what? N is prime. Okay, n is prime. That is what my assumption. N is prime. Okay, let's start here now. So what is the logic, please? If n is divisible by okay, from 2 to n by 2, divisible by, then n is not a prime number. Okay, n is not a prime number. Okay, how we can write the logic? Let us say for I is equal to 2. I is less than is equal to n by 2. Okay, then I plus plus, right? So I am running the loop from 2 to half of the n. Got it? Right. If at all the n is divisible with I may be any number from 2 to half of the number. Okay, if n is divisible with I, divisible means is equal remainder 0. If n modulus I is equal 0, okay, so means n is divisible with I. Okay, if it divisible, okay, this is what, if n is divisible, okay, if n is divisible, then it is not a prime number, so I make boolean variable to false. That's it. Okay, prime is equal to false, and immediately I break the loop. That is what, how to stop the loop? Loop can be stopped by using break. Break means immediately it will come out of this particular for loop. Okay, here I am going to print on the monitor, okay, sys out, let's say that, okay, prime number, okay, prime number is equal to, I just to print the prime, that's it, prime or not, it is going to print the prime. So if it contains true, it will print true. If it contains false, it will print what? False, right? This is how it is going to work. Let me tell you an example. Let me take an example and make you understand, please. Okay, let me make you understand, right? Did I copy this one? Did I copy this one? Let me check once, please. Right, did I copy it? Right. Let us see, please. Wait, right. Let me make the board, right. In this way I make it, right, please understand the program. Let me show you the execution. Assume I have given enter n means, okay, enter n means I have given, assume that 15, okay, na, n is equal to 15. Here I have given n is equal to 15. Here I have given n is equal to 15. Okay, n is equal to 15 I have given. Tell me what is the prime value is? Prime is true. So what is the prime present? So prime assumption is true, means it's a prime number, assume. Now we start the division. Tell me for I is equal to 2. I start with 2. So I am going to write I is equal to 2. Okay, I is equal to, what is the n value, please? N is equal to 15. Okay, n is equal to 15. Okay, right. Now I is less than is equal to n divided by 2. N is 15. 15 divided by 2, 7. Okay, 7. So I 2 is less than is equal to 7. Yes, true. True means go here. Now it is going to calculate n modulus I. Now tell me 15 modulus, okay, 2. What's the remainder is 1. So 1 is equal to 0, no false, come out of the if. Then end of the for loop, I plus plus. I becomes what? 3 now. 3. Now 3 is less than is equal to 7. Yes, true. Again going to the for loop. Again it will divide if n modulus I. So 15 modulus 3. What is the 15 modulus 3, please? 15 modulus 3 is equal to 0 remainder. 0. 0 is equal to 0. Yes, true. Enters here. Prime is equal to false. Now the prime is changed to false, means it is not a prime number. It is not a prime number. Then break means immediately come out of the for loop and say prime is equal to prime. What's the prime is? False. It is going to print the false. Okay. So let me show you the execution. So let me execute the program and I give n is equal to 15. See, 15. So prime is equal to false. Okay. Now let me tell you another one. Let me tell you. Let me erase it. Suppose it is asking enter n, and I have given what, something called as 7. I have given 7. N is equal to how much I have given? 7. Now tell me 7. N is equal to 7. I is equal to 2. And what's the prime is, please? What's the prime is? Yes, prime is equal to true. Initially it is true. Okay. Initially it is true. Okay. Now, what is the value of, right, n is 7. I is equal to 2. I is less than 7 divided by 2 is 3. Okay. 7 divided by 2 is 3. Right. I is equal to 2. So what's the I value now? It is 2. Okay. Right. 2. Okay. The condition is true. Enters here. N modulus I. 7 modulus 2. 7 modulus 2 remainder is 1. So 1 is equal to 0. No false. Come out of. End of the for loop. then I plus plus, I become is now changed to what? 3. Okay, again the condition is true, enters here. If n modulus I, 7 modulus 3, so 7 modulus 3, what the remainder is? Again 1. 1 is equal to 0, no, false, come out of, end of the for loop, I plus plus, I becomes what? 4. Now check the condition, I is 4, 4 is less than is equal to 3, no, false, come out of. Okay, means this n7 is not divisible with any number. Okay, n7 is not divisible with any number, and the prime remained as true only. It didn't enter into the if, so prime remained as what? True. So after the for loop, I am printing the prime. What's the prime is? True. Okay, so therefore I run the program. Here I am giving 7 as a prime number. Okay, now like this. So here I can give you 11, also prime number. Got it? Suppose if I give 25, 25 is divisible with 5, isn't it? Therefore it is a false. Got it? So like this we can say. Now if you want to write a condition, you can also write a condition please. If prime is equal to true, like this also you can put a message please. This out. What is that is? Okay, prime number. Okay, like this, prime number. What is a prime number please? Prime number n is a prime number. Else that is not a prime number. Like this also you can put a messages by using a if statement. Okay, so not a prime number, not prime number n. Like this also we can write it. See, I run the program, n is equal to 7. Okay, true, prime number. Then I give n is equal to 15. Okay, not a prime number, 15. Got it? So like this is a prime number logic, one of the important logics in programming please. So try to remember this particular thing. Okay, so these are the programs. In the next coming class we understand some more programs on the loops. Okay, so thank you.